Technology is reshaping the world faster than ever, and AI and UX/UI artificial intelligence needs user experience helps you make sense of it. We will focus on what it says about user and human. Stay with me, the best part is near the end. Chapter 1: Intelligence and Artificial. Name any field that is full of complex, intractable problems and that has gobs of data, and you'll find a field that is actively looking to incorporate artificial intelligence, AI. There are direct consumer applications of AI, from virtual assistants like Alexa and Siri to the algorithms powering Facebook and Twitter's timelines, to the recommendations that shape our media consumption habits on Netflix and Spotify. MIT is investing over $1 billion to reshape its academic program to create a new college that combines AI, machine learning, and data science with other academic disciplines. The college started September 2019 and will expand into an entirely new space, and even in areas where you'd not expect to find a whiff of AI, it emerges. In the advertising campaign to its new fragrance called Y, Yves Saint Laurent showcased a model who was a Stanford University graduate and a researcher in machine vision. The commercial showcases AI is hip and cool, even displaying lines of Python code, as well as striking good looks to sell a fragrance line. AI has truly achieved mainstream appeal in a manner not seen before. AI is no longer associated with geeks and nerds. AI now sells product. Gavin, The Hobbit, or There and Back Again by J. Tolkien tells of Bilbo Baggins' incredible journey and how he brought his experience back home to tell his tale. That novel opened the door to science fiction and fantasy for me. B.O.B., same for me as well. As I got older, science fiction became more real and approachable. What was once fantasy is now tangible. Consider artificial intelligence. It has gone farther and faster than I would have believed even a decade ago. And while AI did not encounter dragons, wizards, and elves as in The Hobbit, AI did have perils and pitfalls on the journey. Gavin, like Bilbo, the story of AI is a journey that carries lessons to be learned. I think Tolkien's story was not about where the future can take you, but to not forget what the past can teach, inform, and make better. The Hobbit was the prelude to an even bigger story that became The Lord of the Rings. AI may indeed have a great future, but getting it right will require some new thinking. This book is a UX researcher's tale on AI. The point: AI has a long history. Learning from its mistakes made in the past can set the AI of today for success in the future. The world, both inside and outside the tech industry, is abuzz with AI. There must be more to AI than being a company's newest cool thing and giving fodder to marketers. The foundation that unlocks the massive opportunity to answer questions and make human lives easier is the power and intrigue of AI. But its potential is dependent upon having technology work. Because when technology does not work, there are consequences. Gavin, the excitement around AI is white hot. As an example, in healthcare, Virginia Rometty, former CEO of IBM, said that AI could usher in a medical golden age. AI is in the news everywhere. B.O.B., when one thinks of overhyped environments, I think of another golden age, the tulip craze in 17th century Holland. Investing in tulip bulbs became highly fashionable, sending the market straight up. As the hype grew, a speculative bubble emerged where a single bulb hit 10 times an average worker's annual salary. For inevitably the market failed to sustain the crazy prices and the bubble burst. Gavin, like tulip mania, the hype around AI is high, if not irrationally exuberant. But what may be surprising to many is that this is not the first time AI has been hyped up. The boom years of AI in the late 1950s came to a crash in the decade that followed. Virtually all funding for AI was cut, and it took another couple of decades to see investment resume. B.O.B., this slash of funding all things AI spanned a decade. As research began to move into robotics, the accompanying hype around robots led to another crash in the 1980s. AI's history is long and has seen peaks and valleys. My hope is that today's exuberance we will remember the lessons from the past, so this new era of AI will see a more successful future. The point failures have implications and have occurred more than once with AI. Learning from mistakes made in the past can set the AI of today for success in the future. The term artificial intelligence was originated by computer scientists John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon in 1955. They defined AI as making a machine behave in ways that would be called intelligent if a human were so behaving. Of course, this still leaves the definition of AI widely open to interpretation based on the subjective definition of what is intelligent behavior. Needless to say, we know a lot of humans who we don't think behave intelligently. AI's definition remains elusive and changeable. The question, what is intelligence, is outside the scope of this book, fraught as it is with philosophical complications. But, in general, we would support a version of the original definition of artificial intelligence. The domains contained within artificial intelligence all share a common thread of automating tasks that might otherwise require humans to exercise their intelligence. There are alternative definitions, such as the one offered by computer scientist Roger Schank. In 1991, Schank laid out 4 possible definitions for AI as technology that can divine insights with no direction from humans, inference engines that can be fed information about any particular field and calculate proper courses of action, any technology that does something that has never been done by technology before, and we see these as 4 different ways of defining intelligence. Schank endorses the 4th definition, thereby endorsing the idea that learning is a necessary part of intelligence. For the purposes of this book, we will not be using Schank's definition of AI or anyone else's. Doing so would require us to redefine past AI systems, and even some present AI systems, as outside the realm of AI, which we do not intend to do. Machine learning is often a central part of AI, but it's fairly rare. Plenty of AI systems are integrated learning on their own, but they can still accomplish tasks that many would consider intelligent. In this book, we want to discuss as many applications of AI as possible, whether they are capable of learning or not. So, we will define artificial intelligence in the most broad way possible. Artificial intelligence, or AI, has a meaning that is much contested. For our purposes, artificial intelligence is any technology that appears to adapt its knowledge or learns from experiences in a way that would be considered intelligent. A wide variety of technologies can be considered part of AI. So, we've adopted a broad definition of the term. Today's AI applications can do many tasks that were previously thinkable or would require exceptional effort. Machine translators, like Google Translate, can translate between hundreds of languages in a split second at adequate quality for many applications. Medical and business AI can analyze large swaths of data and output insights that can help professionals do their jobs more efficiently. And, of course, virtual assistants allow users to complete tasks such as sending messages and ordering products with that most natural of interfaces, voice. The emergence of artificial intelligence is closely timed with that of user experience, both coming at the advent of the computer age. We'll go over it in more detail in Chapter 2, but suffice it to say that some of the most important innovations in AI and computing in general, neural networks, internet gateways, graphical user interface (GUI), and more were made possible by the work of psychologists turned computer scientists. UX is heavily influenced by psychology, and many of the psychologists' questions were focused on something akin to human-computer interaction, even if some of their work predates the advent of that particular field. AI's definition has centered on using computational methods to accomplish intelligent tasks. We 1T concern ourselves with which complex tasks are intelligent and which aren't. We're more concerned with trying to help make AI more successful by applying a UX-centered approach. Don Norman coined the term user experience in 1993, while working for Apple. In a video for his research organization, the Nielsen Norman Group, Norman describes user experience as a holistic concept, incorporating the entirety of an experience of buying and using a product. 6. He presents the example of purchasing a computer in the 1990s, imagining the difficulty of lugging the computer box into one's car and the intractability of the computer's setup process. He implies that these experiences, even as they are seemingly divorced from the actual functionality of the device, can affect the user's overall perception of the device's functionality. This reveals the all-encompassing nature of user experience. User experience, or UX, asks designers to look at new technologies as experiences, not products. UX designers use models based on social sciences, especially psychology, to design experiences so that users can effectively and efficiently interact with things in their world. If technology doesn't work for people, it doesn't work. 7. Chapter 2: Experience in User. This was an old marketing slogan used by Ameritech, which was a regional Bell operating company, RBOC. Ameritech formed after the breakup of the Bell system monopoly in 1984, where AT&T provided long-distance telephone service while the other box provided local telephone service. Many know box as Pacific Bell, Pac Bell, SBC, Southwestern Bell, 9X, Bell South, US West, and so on. The Ameritech slogan represented the work of a small team of 20 human factors engineers and researchers managed by Arnie Lund. Arnie was a mentor to us, the authors, and to dozens who learned under his leadership. We saw the evolution of human factors to user experience while working for Arnie. The role of this team was to make products work for the user. It seems rather simple that products, of course, need to work as they were intended. But the key is not whether they work for an engineer, but for the user, someone who bought the product or possibly received it as a gift. Think about some products you purchased. Think about the ones with batteries or those that plug into the wall or even connect to the internet. Would you say the setup experience was easy? Unfortunately, there are a lot of products that just make us shake our heads and ask who made it so hard to use. The Ameritech slogan encapsulated the research and design that was needed, not simply to integrate technology into new products but to transform experiences for people as a critical criterion of success. Incorporating a user-centered approach was not the norm in 1995. UX was not table stakes as it is now, but it was such a unique selling point for Ameritech that they featured it in broadcast TV ads. If AI doesn't work for people, IT doesn't work. Gavin, the human factors team at Ameritech, under Arnie Lund, was an amazing group at a special time. For me, it was my first experience applying psychology, research, and user-centered design to make positive changes in a product. Bob, the team included some spectacular minds who were allowed the freedom to make products useful, usable, and engaging at a time before Apple grabbed hold of the Think Different mantra. Gavin, I remember Ameritech as an organization that had tens of thousands of employees, but yet an entire TV advertising campaign was based on the work of a very small team. Bob, the commercials were referred to as the Ameritech Test Town ads. They illustrated how Ameritech's human factors team would test new technology with people in everyday places like diners, cars, and barbershops to ensure that products did not just function, but people could actually use them. Gavin, I remember the ads were memorable and scored high on traditional audience measures. Everyone in the Midwest in the mid-1990s knew the ads. As I remember, the campaign had an ad recall measure that was off the charts good. But, when only half of the respondents thought the ad was about Ameritech, half mistakenly said it was AT&T. Bob, that's true. I'm sure the marketing people were chagrined, but to us, it didn't matter. The point was not to show off some amazing new technology, it was not about slick cutting-edge features. The real message was about the experience. If the person who bought the device could not use it, then nothing mattered. My 88-year-old father still contacts me every other day about how frustrated he is with his computer. Gavin, this was the essence of what made a good UX. And honestly, we have still not come all that far today. Sure, the technology has accelerated, but if the person can't book the trip on a website or program their digital watch easily, then the device is just a digital pet rock because it will get little to no use. Around 20 years have gone by, and while there is certainly an increased awareness of UX, our lives are still as or perhaps even more frustrated by products and services in our world. Bob, as devices get smarter, some people might think they will reduce our frustrations. In fact, there is a school of thought that user interfaces will just fade into the background. They will be the underlying technology, increasingly invisible because they are so intuitive. I am not entirely sold on this yet, but we'll come back to that. For now, as we read on about AI and all that AI promises, the emphasis on how people experience AI seems to be missing. The point: product developers increasingly recognize that good design matters. Understanding how people interact is critical to product success. The Ameritech Test Town commercial showed short vignettes of futuristic technology in everyday life. In one, there was a coffee shop where patrons wore devices. One of those devices frustrated the user because it kept flashing 12 o'clock. Something many of us can relate to. The premise was that there were people who worked at Ameritech who were making products easier to use, products that did not just work, but worked for people. These ads brought attention to the work being done behind the scenes to improve the utility and usability of the technology in Ameritech's new products and services. The field of UX is focused on understanding and improving the connection between humans and technology so that the experience could be more than satisfying. When you think of a user experience, consider adjectives and adverbs that describe the interaction, such as in Figure 1.1. When you design a product or service, you don't want it to simply be satisfying. Sometimes satisfying just means good enough. But isn't that what you hear about? Customer satisfaction? But we argue that a product's success tends to need more than a satisfying experience. When one focuses on the user experience of a product, the interaction design needs to do much more. When you think of something that you really enjoy using, the words you might use are that is addictive, fun, engaging, intuitive, and so on. These are the descriptors that make a user experience great. For success, we must strive for more than satisfaction. We need product to be associated with UX adjectives and adverbs. Adjectives and adverbs that are used to describe interactions. These UX adjectives and adverbs raise the bar for an experience of a product beyond satisfying. We, as UX professionals, can't help but look at AI as simply an application. It is not just about the promise of what AI can do for us. We believe that peering at AI through a UX prism will be instructive. A good UX experience is vital to ensure success and future propagation of AI. UX is our area of expertise, and the thesis of this book is to propose applying UX principles to the design and development of user interfaces to artificial intelligence applications. In the past, AI has been designed by thinking about the functions and the code. What if we could get AI to do X? Designers and developers have big dreams for a mind-bending set of AI applications and set out to achieve them. What we think they ignore all too often is this: once AI can do X, what will it be like to use AI to do X? In other words, developers need to think about what the experience of using their AI product will be like even in the early stages, when that product is just a big idea. It's great to dream that the bot will convert speech to text to action, but if the speech is in a crowded bar and the speaker just had dental work, how useful is the bot? At this point, we posit that an essential element in AI's success hinges on understanding and improving the user experience, not on giving AI all manner of new functions. Most AI applications already have plenty of useful functions, but what good are functions if the user can't use them or doesn't know how to access them? Having a good initial experience goes a long way. So much time and effort goes into product design. When a bad experience happens, sometimes I think how close the designers came to getting it right. What could the team that made it have done to get it right? There is often a fine line between success and failure. Gavin, yeah, think of voice-enabled calling in a car. The auto manufacturers have had this around for a decade. But now, almost everyone has a phone. How many use the voice feature in their vehicles? The old adage of fool me once, shame on you. Fool me twice, shame on me might apply to human interactions, but human to AI interactions is more like, fail me once and you tend to not try again. Exactly. Imagine a mom driving a car full of kids to a soccer game. She tries to use voice calling in the car. If the mom hears, I don't understand that command, do you think she will ever try again? Will she realize the ambient background noise, children playing, might have interfered with AI's ability to understand? Most won't. Gavin, applying this logic to all the technology around us, this need for a good user experience goes beyond voice calling. Think about the effort that goes into the design of the 500+ features in a BMW 540, for example. So much time and cost goes into building these features. But, how many do people actually use? Just because a feature is there doesn't mean it's useful or usable. UX focuses on more than how the feature works. Half the battle is helping people get to the feature. Once accessed, does the feature map to how people expect it to work? These are core principles of good design. AI is not a panacea. Understanding how users will interact with this output is the experience. And that's where focus on the UX is key. The point products embedded with new technology do not automatically ensure success. A positive interaction is essential. With UX described as an important driver for success, how UX integrates into AI-enabled products starts with the introduction of a UX framework, which will lay the foundation for topics in this book. The UX framework is our method of considering user experience while designing an AI application. This framework is rooted in classic user-centered design where the user is at the center, not technology. Chapter 3: User Indifference. In order to understand how a UX framework can be applied to AI, we'll consider these 3 AI UX principles: context, interaction, and trust. These are independent dimensions that make up our UX framework for AI. We will cover this model in depth in later chapters, but it is instructive to give a small tasting of these now. AI UX principles that need to be addressed when designing AI products and services. The next wave of AI needs to be designed with a UX framework in mind or risk the further limiting of acceptance. Good UX for AI applications will propel growth. In recent years, IBM spent $4 billion on acquisitions and expenses in the healthcare sector, mostly to boost the capabilities of its new medical AI, Watson Health. The results have been mixed. Watson Health has shown some incredible promise, but it's also stagnated. The Wall Street Journal published a scathing article about Watson Health's failures, and the article alleged that more than a dozen clients have cut back or altogether dropped their usage of Watson Health's oncology, cancer treatment programs, and that there is little to no recorded evidence of Watson Health's effectiveness as a tool for helping patients. In 2017, Watson Health's ability to create cancer treatment plans was tested for agreement with doctors' recommended treatment plans in both India and South Korea. When Watson was tested on lung, colon, and rectal cancer patients in India, it achieved agreement rates ranging from 81% to 96%. But when it was tested on gastric cancer patients in South Korea, it achieved just 49% agreement. Researchers blamed the discrepancy on the diagnostic guidelines used by South Korean doctors, which differed from those Watson was trained on in the United States. 11. Don't limit AI to imitating human behaviors. Bob. So Watson learned how to diagnose and recommend cancer treatments using a US dataset. Everyone cheered when Watson recommended treatment plans that US doctors recommended. But, when applied to South Korean cases, it missed the mark. But, is this the criterion for success? Replicating what US doctors do? Gavin, this is the point. AI should not merely replicate. The fact that AI found a difference is noteworthy. Perhaps we need to change our thinking. AI found a difference. And this is the insight. AI is raising its hand and effectively asking, what are South Korean oncologists doing that US oncologists are not? And why are they making those decisions? Instead, many interpreted this as an inability to imitate human decision-making and therefore Watson failed. Bob, yes. Improving health outcomes is the goal, not whether a computer's recommendations correlate to a human. AI's contribution asks us to investigate the difference in treatments. This might advance care by looking at the differences to find factors that improve outcomes. It is the difference that might help. The point: we limit AI by determining success on whether its outcomes correlate with human outcomes. This is merely the first step where AI can identify differences. Knowledge is furthered when this insight spurs more questions. This leads to the ultimate goal: better health outcomes. When we make the goal about replicating human outcomes, we do a disservice to AI. Ideally, Watson should be applauded for identifying that there is a difference in treatment plans between US and South Korean cases. AI does not have to solve the entire problem. Finding a difference that was previously unknown is a big step. AI alerted us to a difference. Now, we can investigate and possibly save lives. This is a good example of engaging more than just programmers with the challenge of making AI solve problems. Let us take control and design a product with AI as a team. Bring in product teams, programmers, oncologists, and even marketing to approach the problem and not assume AI will figure it out by itself. We'll talk more about AI examples, like Watson Health in Chapter 3, but for now, suffice it to say that it is one example of how AI can stagnate without an awareness of context. Context includes the outside information that AI can use to perform a task. It includes information about the user and why they are making the request, as well as information about the external world. Those who work on AI-enabled products need to understand the context of its output, what its output means, how it compares to objectives and expectations, and more. Gavin's college roommate at the University of California, San Diego was Craig Neese, who studied computer science. He went on to help develop Falcon, a pioneering AI algorithm that detected credit card fraud in the early 1990s. Gavin talked to Craig while working on this book, and Craig explained how he used a type of AI known as a neural network to detect suspicious purchases. Falcon incorporated variables like geographic location and types of stores to give each transaction a score. High-scored transactions meant a phone call to the cardholder and a possible canceled transaction. This worked well in many situations, including situations of actual fraud. But it had trouble with false positives, in which it marked non-fraudulent purposes as fraudulent. One particularly problematic case was international trips. Back in the 1990s, not everyone had a cell phone, and even those cell phones that were around had difficulties with international calling. If you didn't have your working phone on you, or the credit card company neglected to call, you were liable to lose your credit card for your entire international trip. Of course, this could spell disaster. Today, there is only one additional step involved. The credit card companies still use similar fraud detection mechanisms, identifying likely fraudulent purchases by geographic location and store type, among other factors. But now, thanks to the ubiquity of smartphones, not to mention the increasing coverage of mobile data and Wi-Fi networks, your credit card company can send an alert to your phone that asks whether or not you made the suspicious purchase in question. If you did, you can tap yes and your purchase will go through just fine. That additional interaction with the user makes a world of difference. Interaction refers to AI engaging the user in a way in which they can respond. That engagement could come in many forms: a message in the AI's interface, a text message, a push notification to their smartphone, etc. When the AI system makes its conclusion that the purchase is likely fraud, it doesn't act immediately to cancel the transaction and lock down the card. Instead, the AI algorithm has a convenient way to reach out to the user and make sure that the users don't object to it taking this action. While this request for user consent is not foolproof, e.g., perhaps the user's phone has been stolen alongside the card, or it is out of battery, it works better than the old method of giving the user a phone call. It's a more effective interaction, a necessity when the possible impacts are so great. Before AI takes a potentially impactful action on a user's behalf, it should attempt to interact with the user. Communication is key. This is the experience that AI needs. The interaction needs to be designed. When you think of trust relative to a device interaction, the initial expectation is that the device does what it is supposed to do. But from a UX perspective, trust can go further. Here is an example. If you are familiar with the iPhone, when you hear the Siri startup beep, what is your reaction? You might recoil a little. Ugh, I accidentally pressed it again. But why does Siri deliver such a negative visceral reaction in many of us? It's supposed to be a helpful tool, after all. Why don't we trust it? Trust is when users feel that an AI system will successfully perform the task that a user wants it to perform, without any unexpected outcomes. Unexpected outcomes can include performing additional, unnecessary or unhelpful tasks that the user did not ask for, or breaching the user's privacy in a way that the user could not have anticipated. Trust is sticky, that is, if a user trusts a service, they're likely to keep trusting it, and if they don't trust it, they're likely to continue to mistrust it. Siri is one of many voice assistants that listen for spoken commands. The voice assistant recognizes phrases and processes the information. Consider the example described in the car full of kids with the mom engaging a voice feature. In the early days of voice assistants, the AI system listened for simple grammar that took a verb plus subject and turned it into a command, like, call, Dad. As the technology continued to improve, dictation of speech to text became more accurate. A voice assistant, or virtual assistant, is an AI-based program that allows users to interact with an application through a natural language interface. Virtual assistants have tens of thousands of applications available to users that can perform all manner of tasks for the user: get weather, make cat sounds, tell jokes, sing songs, etc. When Siri was first released in 2011 on iPhones, in what Apple termed a beta version, 12 early reviews were met with cheer and accolades. Finally, there was a voice-based interface. Unfortunately, the honeymoon did not last long. Users began to express frustration and strong negative associations formed. As examples, Siri had issues with both usability and functionality. Siri could be triggered accidentally and its speech recognition was not nearly as robust as users expected. All too often Siri would apologize and say, "Sorry, I don't understand," and even if it did properly recognize the speech, it frequently misconstrued the request. Very quickly, users also wanted to do more with it than it was designed for. In short, users, customers, originally had in their minds an application with such great promise, but the reality was exceedingly modest. Apple had a failure on their hands. 13. Chapter 4: Design and Affordances. Trust is formed by more positive experiences. BOB. For any product, whether it has AI or not, the bare minimum should be that it be usable and useful. It needs to be easy to operate, perform the tasks that users ask of it accurately, and not perform tasks it isn't asked to do. That is setting the bar really low, but there are many products in the marketplace that are so poorly designed where this minimum bar is not met. Gavin, just think about how many TV remotes sit on the coffee table of your living room and the sheer number of buttons. It makes you question how much effort went into the design of the remote. Consider the experience of using the remote. It is often at night. BOB, the worst is the remote that controls the TV settings. Sometimes we fumble in the dimly lit room and accidentally press the wrong button on the remote. When you fumble in the dark, how often has a menu or setup pop-up window appeared when you thought you pressed the back button? Gavin, the design challenge becomes even more difficult when we move to AI. Think about the Siri experience, which is entirely independent of a screen interface like one on a TV. Because everything happens by voice, the dialogue needs to be well developed. It must work or people will abandon it. BOB, when things work well or the experience is good, one forms a feeling of trust. And when the voice dialogue on Siri does not work, what happens next? Repeat the phrase? But how many times would someone try? This delivers a feeling of mistrust. Gavin, this is important because it can explain why Siri has fallen into disuse. After multiple failures, trust evaporates. The result is that people just stop using the product. BOB, and with a voice assistant, the feeling can be persistent. Let us say Apple made Siri better and solved some of the "I am sorry, I don't know that yet" interactions. How would you know? Gavin, all that effort put in to make Siri smarter would be for naught. This puts the product on a downward path where it is difficult to recover. The point: our perception of a product is the sum total of the experiences that we have with that product. Does the product deliver the value we had hoped? Our willingness to trust the product hangs in that balance. The field of behavioral economics, which combines psychology and economics, has provided insights that are critical to the pillar of trust in UX. Daniel Kahneman, a Nobel Prize winner and critical figure in behavioral economics, divides the brain into two systems. 14. System 1 is the system of passions that guides the brain. It offers the intuitive judgments that we make constantly and governs our emotional responses to situations. System 2 is the system of reason. It comes to consider judgments after long periods of analysis. Kahneman wishes to subvert the conventional wisdom that rational thinking is always superior to emotion and that poor decisions usually come from following instincts rather than reason. Kahneman points out that intuition is often effective. System 1 is what allows us to drive a car, maintain most of our social relationships, and often even to answer intellectual questions. Behavioral economists like Kahneman have proposed three important heuristics, or mental shortcuts, that are used often by System 1: affect, availability, and representativeness. For our purposes, we are going to focus on the affect heuristic. The affect heuristic dictates that our initial emotional judgments of someone or something will dictate whether or not we trust that person or thing. 15. This is what sank Siri. Initially, the virtual assistant was cumbersome to use, and that affective association of negative feelings with Siri lingered even after the service itself was improved. In 2014, Amazon came out with its Echo, featuring the Alexa virtual assistant. The device presented the virtual assistant with a particular use scenario in mind, one that was particularly accommodating to virtual assistant use. In the home, where the Amazon Echo is meant to sit, you're less likely to feel ashamed about talking to your tech. That's not the only difference between the Echo and Siri. The Echo also looks completely different, sitting as it does in a cylindrical device that is dedicated entirely to its use. Amazon worked hard to make sure that its virtual assistant, Alexa, would provide a good experience from its inception. They may have been inspired by the failure of Amazon's Fire Phone just a couple years earlier. The Fire Phone seemed like a minimum viable product, 16, and it flopped out of the gate. But the Echo was different. While building the Echo, Amazon ran tests, including the Wizard of Oz test. In that test, users asked questions, which were fed to a programmer in the next room, who typed in responses that were then played in Alexa's voice. 17. Amazon used the test to analyze the vocal attributes that got the best response from users. Amazon took the time and effort to build a product that would engender trust, and it showed. We don't exactly know what user research Apple did with Siri, but whatever they did, the outcome was not as successful as it was for Amazon. Trust is vitally important to user adoption, and it's easily lost. Developers need to be careful to design an experience that engenders trust. At the core of the UX outlook on design is the concept of affordances, developed by psychologist James Gibson. Affordances are points of interaction between object and perceiver that allow the perceiver to understand the object's features, the things that the object can do for the perceiver and for other agents. 18. Gibson sees these properties as extant in the universe. Certain affordances are easy for us to discover, perhaps directed by cultural norms for using an object or by the object's design. Doors with flat plates afford pushing, while doors with loop handles afford pulling. Google's homepage is dominated by a single text box with a search button and lots of white space, indicating that it allows you to search for anything you'd like. Recognition of the power affordances have to provide information to the user is woven into the design of the product to improve usability, function, and use. However, some of an object's features may be less clear, meaning that the corresponding affordances are only present for users who are in the know. For tech products, these are the kind of features that end up being revealed to users by accident or through viral online articles. They have titles like 10 Things You Didn't Know Your Phone Could Do. If the user does not know that the object has a certain function made clear by an affordance, that function becomes much less useful. Whenever the number of functions exceeds the number of affordances, there is trouble. Therefore, the designer must be skilled at communicating to the user what the object is capable of. In other words, the designer must create signifiers, another term from Norman, that communicate the object's affordances, Google's search box. 19. Affordance generation is two-sided. An object must have certain properties, and a user must recognize possible functions for those properties. For this reason, users of products may discover affordances that the designer never intended. For example, Facebook likely intended its groups feature to link real-life groups of friends, coworkers, and classmates, but many users have instead used them to share memes and inside jokes with like-minded strangers. Facebook seems to have welcomed the opportunity to retain younger users, even rolling out a new screening feature that particularly helps meme-based groups. 20. After users discovered a new affordance for Facebook's Groups feature, Facebook updated its product to reflect a use case that they were never planning for. This is illustrative of the active role that users can play in further shaping the design. Design needs to recognize the many ways that a user might use a feature. Gavin, sometimes the user's needs can come in conflict with the aspirations of the designer. Consider Apple's $5 billion state-of-the-art headquarters built in 2018 by architect Norman Foster. The building used rounded glass that was designed to achieve an exact level of transparency and whiteness. 21 Bob, the problem was that people could not tell where the door ended and the wall began. And even the building inspector cautioned on this risk. But to the architect, it was all about the design and not about those affordances. Gavin, what happened? Workers walked right into the glass so hard that 911 was called 3 times in the first month. Employees were so fearful that they placed their own affordances on the wall sticky notes to prevent more injuries. Bob, but the building designers removed the sticky notes because it was said to have detracted from the building's design aesthetics. Gavin, not only is this ironic that it happened at Apple, but talk about architects not living in the places they design. We've heard that Apple-approved stickers were made after that to provide better affordances to distracted walkers in an attempt to reduce 911 calls due to injuries. The point, sometimes the design sake can get in the way. How users actually engage, or in this case, walk, can often be at odds with the aesthetic. Design needs to work for the whole user, not simply what the eye sees. The user-centered design ethos that is at the core of UX differs from the stereotypical association of the term design with form and aesthetics. While form and aesthetics are certainly important components of an experience, they need to be combined with functionality in order to deliver the best possible experience to the user. UX design focuses on the ways in which form and function can complement one another, without compromising either one for the other. This vision of design was well articulated in a lengthy opinion piece co-authored by Don Norman and Bruce Tognazzini in 2015, criticizing the design of Apple's operating system for its smartphones and tablets. 22 Norman and Tognazzini, who had both worked for Apple during the pre-iDevice days, felt that Apple had once been a leader in user-centered design, but that it had since lost its compass. They centered their criticisms around iOS's lack of certain useful affordances, such as a universal back button to undo actions, as well as its lack of signifiers for many of the affordances it does have. Chapter 5: Human and Computer. Apple's gestural interfaces rely on the concept of second nature. Human beings are built to learn and adopt new systems of interacting with the world and quickly become so familiar with them that they become instinctive. 23 This is what we have all done with swiping around our phones, pinching to zoom in and out, and the rest of the gestures that allow us to use smartphones and tablets. Apple, however, has gone the extra mile with its gestural interfaces, working in all manner of different gestures. To see this in action, all you have to do is go to an Apple store and swipe all of the various devices there with 3 fingers or your palm in different directions and patterns. Odds are the device will start to do lots of unexpected functions. The problem that Norman and Tognazzini identify is that most users have no natural way of discovering these gestural features. There are no on-screen indicators that these features are present, and very few users are going to experiment with the OS or read the manual in order to find out about them. So, for all intents and purposes, these features don't exist for most users except to confuse them when they accidentally trigger them while trying to do something else. That leads to negative interactions. Users' perception of their experiences is vital to their continuing to return to those same experiences time again. People will generally tend to build patterns of engagement with objects in their world that they consider to be profitable and enjoyable. UX describes the holistic experience of interacting with a product. Bob, if I need to get something done, I'm not going to use an iPad. I'm not going to use a smartphone. I'm certainly not going to tell Alexa. I'm going to turn on my computer and point and click my way through a complicated task. And that's not just because it has a faster processor, it's because a computer is easier to use with respect to complicated tasks. Gavin, Norman, and Tanya Zini pointed it out. When Xerox and Apple were working on the first point-and-click graphical user interfaces, they had UX principles in mind even if the term wasn't invented yet. Bob, today, with touch interfaces, it seems like that's backward. The technology that enabled multi-touch interactions seemed to be natural gestures, as Steve Jobs called them. In many ways, the gesture itself took precedence over the function. There was almost a look of disgust at those who did not know how to pinch, swipe, or flick with their fingers to interact with the iPhone. It was as if the gesture was more important than the function itself. Gavin, Apple's first commercials on the iPhone, which were incidentally paid by AT&T in the US launch in 2007, were all about how to use the iPhone. It was as if Apple made the purpose of their commercials to show the user manual. This was a phenomenal sleight of hand. Who spends hundreds of millions in marketing to show people how to use a product? And Apple argued that touch was so simple, but what came first, the user manual commercials or the gesture? Bob, this is a critical consideration as we move into a new era of AI. It seems like we didn't really master how to maximize functionality in touch interfaces to the extent that we did with point-and-click interfaces. But while we try to fix that, we're going to have to turn some of our attention elsewhere. AI brings up all types of new interface possibilities. Voice interfaces are the obvious one, thanks to the virtual assistant. But there's more. There are gestural interfaces where there is a camera watching for movement, like raising your hand in front of Smart TV or like the Microsoft Kinect. Computers are starting to read facial expressions and detect effect even being present in a room as data to AI. Down the road, there may even be neural interfaces, brainwaves going directly from your brain to the computer. Bob, neural interfaces are a ways away. But I get what you mean, especially with voice. Voice interfaces are a difficult case for usability, even more so than touch, because there are fewer opportunities to communicate affordances to the user. Without any visual signifiers, UX gets a lot harder. With screen-based interfaces, as a designer you can provide visual affordances and rely on people's ability to recognize information. With voice, the interface is natural language appearing to be wide open to the infinite number of sentences and questions that I could ask. Gavin, these are important questions that we're facing in tech right now. But UX people aren't always in the room where the decision makers are, and, more often than not, they should be. The point UX describes the holistic experience of interacting with a product. In the next chapter, we will look at the simultaneous, but independent development of the fields of AI and UX, then called human-computer interaction or human factors, and consider the relevant historical and intersectional points that help us to glean lessons from the past and move toward better design. We'll also discuss the legacy of a few psychologists and how their work shaped both UX and AI. In Chapter 3, we will examine the state of AI today and where UX is and ISNT coming into play. We will also take a look at some of the psychological principles underlying human-computer interaction, a key component of interaction. In the later chapters, we will propose and justify our UX framework for AI success and discuss its implications for the future. Lou R. Schumacher Jr. AI and UX https://doi org/978-1-4842-5775-3_2. In this chapter, we're going to take you through some key milestones of both AI and UX, pointing out lessons we take from the formation of the two fields. While the histories of AI and UX can fill entire volumes of their own, we will focus on specific portions of each. If we step back and look at how AI and UX started as separate disciplines, following those journeys provides an interesting perspective of lessons learned and insight. We believe that at the confluence of these two disciplines is where AI will have much more success. UX is a relatively modern discipline with its roots in the field of psychology. As technology emerged, it became known as the field of human-computer interaction, HCI. HCI is about optimizing the experience people have with technology. It is about design, and it recognizes that a designer's initial attempt on the design of the product might require modification to make the experience a positive one. We'll discuss this in more detail later in this chapter. As such, HCI emphasizes an interactive process. At every step of the interaction, there can and should be opportunities for the computer and the human to step back and provide each other feedback, to make sure that each party contributes positively and works comfortably with the other. AI opens up many possibilities in this type of interaction, as AI-enabled computers are becoming capable of learning about humans as a user in the same way that a real flesh-and-blood personal assistant might. This would make a better calibrated AI assistant, one far more valuable than simply a tool to be operated, a partner rather than a servant. The exact start of AI is a subject of discussion, but for practical purposes, we choose to start with the work of computer scientist Alan Turing. In 1950, Turing proposed a test to determine whether a computer can be said to be acting intelligently. He felt that an intelligent computer was one that could be mistaken for a human being by another human being. His experiment was manifest in several forms that would test for computer intelligence. The clearest form involved a user sending a question to an unknown respondent, either a human or a computer, which would provide an answer anonymously. The user would then be tasked with determining whether this answer came from a human or from a computer. If the user could not identify the category of the respondent with at least 50% accuracy, the computer would be said to have achieved intelligence, thereby passing the Turing test. The Turing test is a procedure intended to determine the intelligence of a computer by asking a series of questions to assess whether a human is unable to distinguish if a computer or human is giving responses. The Turing test has become a defining measure of AI, particularly for AI opponents, who believe that today's AI cannot be said to truly be intelligent. However, some AI opponents, such as philosopher John Searle, have proposed that Turing's classification of machines that seem human as intelligent may have even gone too far, since Turing's definition of intelligent computers would be limited to machines that imitate humans. Searle argues that intention is missing from the Turing test and the definition of AI goes beyond syntax. Elon Musk takes a similar view of intelligence to Searle, proposing that AI simply delegates tasks to constituent algorithms which consider individual factors and does not have the ability to consider complex variables on its own, so this would argue AI is not really intelligent at all. As far as we know, no computer has ever passed the Turing test, though a recent demonstration by Google Duplex, making a haircut appointment, was eerily close. The Google Duplex demonstrations are fascinating as they represent examples of natural language dialogue. The recordings start with Google's Voice AI placing a telephone call to a human receptionist to schedule a hair appointment and a call to make a reservation with a human hostess at a restaurant. What is fascinating is the verbal and non-verbal cues that were designed into the computer voice, such as pauses and inflection by Duplex, were interpreted by the human successfully. On face, Duplex engaged into a conversation with a human where the human does not appear to realize that a machine is operating at the other end of the call. It's unclear how many iterations Google actually had to go through to get this example. But, in this demonstration, the machine through both verbal and non-verbal cues seemed to successfully navigate a human conversation without the human showing any knowledge of or negative reaction to the fact that it was a machine that was calling. Bob, regardless of whether or not the Turing test is a sufficient litmus test for the presence of AI, it's had a profound influence on how we define AI. Gavin, the Turing test has captured the attention of the masses interested in the future of AI. The Turing test has an inherent simplicity as a game of imitation and asked the question, can a computer fool a human? Bob, popular science fiction elevated the Turing test in movies, such as Ex Machina, which was explicit in its use of the Turing test, and Blade Runner, where the protagonist played by Harrison Ford tests whether a woman is a human or replicant. Gavin, Turing's influence on computing and our perception of intelligence is undeniable, that's for sure. The point throughout the short history of AI, there has been a desire to make the AI have human qualities. As AI continues to evolve, one trap that needs to be avoided is to advance a definition of AI that juxtaposes AI against a human. This might be too limiting to where AI that complements human decision-making would be undervalued. Put simply, there is more to AI than conversation. Moreover, by simply defining intelligence based on Turing's test, the development of AI could lead to a belief that a program seems more intelligent than it actually is. Chapter 6: Machine and Program. One of the most notorious programs in computer science was written in 1966 by Joseph Weizenbaum, a professor at MIT. The program was called ELIZA. The name comes from George Bernard Shaw's play, Pygmalion, in which Eliza Doolittle studies elocution and etiquette. In this program, Weizenbaum modeled the interaction similar to how a Rogerian psychotherapist might respond to a patient. The person simply types responses to the questions Eliza asked. Example of Eliza conversing with a person: Eliza, how long have you been feeling depressed? Person, I don't want her to get into trouble. Eliza, what would it mean to you if she got into trouble? The point: this conversation between the user and the program left an impression that Eliza embodied human-like intelligence. Because the dialogue felt natural, the computer must be intelligent. But, did this constitute intelligence? Is all that is necessary for intelligence is to fool a human? Eliza was successful and people may have poured their lives into it. But, in all of these conversations, there was no learning algorithm to carefully analyze the data. In fact, not much of what was typed was saved, as this was 1966. Some proclaimed that Weizenbaum had solved natural language through his program. Weizenbaum ended up on a crusade against his own program. 7 Eliza was more of a Carl Rogers parody. The program did not know psychology, just semantic logic to reflect questions back. But because the program felt human, intelligence was bestowed to it. This is an example of AI that can capture the imagination of the masses. And this makes AI susceptible to being overhyped. With Eliza, the hype was brought about from the users. In other examples, hype can come from its creators, investors, government, media, or market forces. Historically, AI overpromised and underdelivered. In the past, artificial intelligence has had something of an image problem. In 2006, the New York Times' John Markoff called AI a technology field that for decades has overpromised and underdelivered. 8 in the lead paragraph of a story about an AI success. One of the earliest attempts to develop AI was machine translation, which has its genesis in the post-World War II information theories of Claude Shannon and Norbert Weaver. There was substantial progress in code breaking as well as theories about universal principles underlying language. 9 Machine translation is the translation of one language into another via a computer program. Machine translation's paramount example is the now, in famous Georgetown IBM Experiment 10, where in a public demonstration in 1954, a program developed by Georgetown University and IBM researchers successfully translated many Russian language sentences to English. This demonstration earned the experiment major media coverage. In the heat of the Cold War, a machine that could translate Russian documents into English would have been very compelling to American national defense interests. A number of headlines the bilingual machine, for example, greatly exaggerated the machine's capabilities. 11. This coverage was accompanied by massive investment leading to wild predictions about the future capabilities of machine translation. One professor who worked on the experiment was quoted in the Christian Science Monitor saying that machine translation in important functional areas of several areas might be ready in 3-5 years. 12. Hype was running extremely high. The reality was far different. The machine could only translate 250 words in 49 sentences. Indeed, the program's focus was on translating a set of narrow scientific sentences in the domain of chemistry, but the press coverage focused more on a select group of less specific examples which were included with the experiment. According to linguist W. John Hutchins, 13. Even these few less specific examples shared features in common with the scientific sentences that made them easier for the system to analyze. Perhaps because of these few contrary examples, the people covering the Georgetown IBM experiment did not grasp the leap in difficulty between translating a defined set of static sentences to translating something as complex and dynamic as policy documents or newspapers. The Georgetown IBM translator may have seemed intelligent in its initial testing, but further analysis proved its limitations. For one thing, it was based on a rigid rules-based system. Just 6 rules were used to encode the entire conversion from English to Russian. 14. This, obviously, inadequately captures the complexity of the task of translation. Plus, language only loosely follows rules for proof. Look no further than the plethora of irregular verbs in any language. 15. Not to belabor the point, but the program was trained on a narrow corpus and its main function was to translate scientific sentences, which is only an initial step towards translating Russian documents and communications. This very early public test of machine translation featured AI that seemed to pass the Turing test, but that accomplishment was deceptive. Don't believe that the power of computing can overcome all. Gavin. The Georgetown IBM experiment was a machine language initiative that started as a demonstration to translate certain chemistry documents. And this resulted in investment that spurred a decade of research in machine language. B.O.B. Looking back now, you could argue the logic of applying something that marginally worked in the domain chemistry to be generalized to the entire Russian language. It seems overly simplistic, but, at the time, this chemistry corpus of terms might have been the best available dataset. Over the past 70 years, the field of linguistics has evolved significantly, and the nuisances of language are now recognized to be far more complex. Gavin, nevertheless, the fascination that the power of computing would find patterns and solve mutual translation between English and Russian is an all too common theme. I suspect that the researchers were clear in the limitations of the work, but as with Greenspan's now famous irrational exuberance quote that described the hype associated with the stock market, expectations can often take on a life of their own. The point: we must not believe that the power of computing can overcome all. What shows promise in one domain, chemistry, might not be widely generalizable to others. The Georgetown and IBM researchers who presented the program in public may have chosen to hide the flaws of their machine translator. They did so by limiting the translation to the scientific sentences that the machine could handle. The few selected sentences that the machine translated during the demonstration were likely chosen to fit into the tightly constrained rules and vocabulary of the system. 16. The weakness of the Turing test as a measure of intelligence can be seen in journalists' and funders' initial, hype-building reactions to the Georgetown IBM experiment as deceptively human-like results. 17. Upon witnessing a machine that could seemingly translate Russian sentences with the near accuracy of a human translator, journalists 18 must have thought they had seen something whose capabilities significantly outstripped the reality of the program. Yet these journalists were ignorant or unaware of the limited nature of the Georgetown IBM technology, and the organizers of the experiment may have nudged them in that direction with their choices for public display. If the machine had been tested on sentences outside the few that were pre-selected by the researchers, it wouldn't have appeared to be so impressive. Journalists wrote articles that hyped the technology's capability. But the technology wasn't ready to match the hype. Nearly 60 years later, machine translation is still considered imperfect at best. 19. Hype can play a large influence on whether the product is judged a success or failure. Chapter 7: Machine in Translation. A most devastating consequence of this irrational hype was the suspension of funding for AI research. As described, the hype and perceived success from the Georgetown IBM experiment resulted in massive interest and substantially increased investment in machine translation research. However, that research soon stagnated as the difficulty of the real challenge associated with machine translation began to sink in. 20. By the late 1960s, the bloom had come off the rose. Hutchins specifically tied funding cuts to the Automatic Language Processing Advisory Committee (ALPAC) report, released in the ALPAC report, sponsored by several U.S. government agencies in science and national security, was highly critical of machine translation, implying that it was less efficient and more costly than human-based translation for the task of translating Russian documents. 22. At best, the report said that computing could be a tool for use in human translation and linguistic studies, but not as a translator itself. 23. The report went on to say that machine-translated text needed further editing from human translators, which seemed to defeat the purpose of using it in place of human translators. 24. The conclusions of the report led to a drastic reduction in machine translation funding for many years afterward. In a key portion, the report used the Georgetown IBM experiment as evidence that machine translation had not improved in a decade's worth of effort. The report compared the Georgetown IBM results directly with results from subsequent Georgetown machine translators, finding that original Georgetown IBM's results had been more accurate than advanced versions. That said, Hutchins defined the original Georgetown IBM experiment as not an authentic test of the latest machine translation technology but as a spectacle intended to generate attention and funds. 25. Despite this, ALPAC judged later results against Georgetown IBM as if it had been a true showing of AI's capabilities. Even though machine translation may have actually improved in the late 1950s and early 1960s, it was judged against its hype, not against its capabilities. As machine translation was one of the most important early manifestations of AI, this report had an impact on the field of AI in general. The ALPAC report and the corresponding domain-specific machine translation winter were part of a chain reaction that eventually led to what is considered the first AI winter. 26. An AI winter is a period when research and investment into AI stagnates significantly. During these periods, AI development gains a negative reputation as an intractable problem. This leads to decreased investment in AI research, which further exacerbates the problem. We identify two types of AI winters: some are domain-specific, where only a certain subfield of AI is affected, and some are general, in which the entire field of AI research is affected. Today, there are lots of different terms for technology that encapsulate AI expert systems, machine learning, neural networks, deep learning, chatbots, and many more. Much of that renaming started in the 1970s, when AI became a bad word. After early developments in AI in the 1950s, the field was hot, not too different from right now, though on a smaller scale. But in the decade or two that followed, funding agencies, specifically US and UK governments, labeled the work a failure and halted funding the first ever general AI winter. 27 AI suffered greatly from this long-term lapse in funding. In order to get around AI's newfound negative reputation, AI researchers had to come up with new terms that specifically did not mention AI to get funding. So, following the AI winter, new labels like expert systems emerged. Given the seeming promise of AI today, it may be difficult to contemplate that another AI winter may be just over the horizon. While there is much effort and investment directed toward AI, progress in AI has been prone to stagnation and pessimism in the past. If AI does enter another winter, we believe a significant contributing factor will be that AI designers and developers neglected the role UX plays in successful design. There is another contributing factor, and that is the velocity of technology infusion into everyday life. In the 1950s, many homes had no television or telephone. Now the demands are higher for applications. Users will reject applications with poor UX. As AI gets embedded into more consumer applications where user expectations are higher, it is only inevitable that AI will need better UX. The first AI winter followed the ALPAC report and was associated with a governmental stop to funding related to machine language efforts. This investment freeze lasted into the 1970s in the United States. Negative funding attention and news continued with the 1973 Lighthill report, where Sir James Lighthill reported to English Parliament results similar to those of ALPAC. AI was directly criticized as being overhyped and not delivering on its promise. 28 Bob. So, was it that the underlying theory and technology in the Georgetown IBM experiment were flawed, or was it just hype that created the failure? Gavin, I think it was both. The ALPAC report pulled no punches and led to a collapse in any research in machine translation, a domain-specific AI winter. Huge hype for machine translation turned out to be misplaced, and the result was a significant cut in funding. Bob. Yes, funding requests with the terms machine translation or artificial intelligence disappeared. Not unlike the old adage of throwing the baby out with the bathwater, a major failure in one domain makes the whole field look suspect. That's the danger of hype. If it doesn't match the actual capabilities of the product, it can be hard to regain the trust. Gavin, the first general AI winter formed a pattern of initial signs of promise, to hype, to failure, and subsequently a freeze in future funding. This cycle led to significant consequences for the field. But scientists are smart. Out from the ashes, AI bloomed again, but this time using new terminology such as expert systems, which led to advancements in robotics. Bob. So, under its new names, AI garnered over $1 billion in new investment in the 1980s, ushered in by private sector companies in the United States, Britain, and Japan. Gavin, actually, Japan's advances in AI spawned US and British international competition to keep up with the Japanese. Notable examples are the European Strategic Program on Research and Information Technology, the Strategic Computing Initiative, and Microelectronics and Computer Technology Corporation in the United States. Unfortunately, hype emerged again, and when these companies failed to deliver on the lofty promises, the second AI winter 29 was said to occur in 1993. The point AI has seen boom and bust cycles multiple times in its history. Can another AI winter happen? It already did. Often lessons from the past are ignored with the hope that this time will be different. Will another AI winter happen in our lifetime is not the question, because one happened before our very eyes. Consider Apple's voice assistant, Siri. Siri was not launched fully functional right out of the gates. The beta version was introduced with a lot of fanfare. Soon Apple pulled it out of beta and released more fully fledged versions in subsequent updates to iOS versions that were far more functional and usable than the original. The potential for many users to adapt to it was greatly reduced. However, Siri users had already formed their impressions, and considering the AI UX principle of trust, those impressions were long-lasting. Not to be too cheeky, but one bad apple, released too early, spoiled the barrel. B.O.B., look, to the Siri fans out there, Apple did an amazing job relative to previous voice assistants. When working for Baby Bell companies many years back, we often tested voice assistants. Siri was a generation ahead of anything we had in our labs. Gavin and Siri was the first ever virtual assistant to achieve major market penetration. In 2016, industry researcher Carolina Milanesi found that 98% of iPhone users had given Siri at least one chance. 30. This is a phenomenal achievement in mass use of a product. B.O.B., the problem though was continued use. When 98% were asked how much they used it, most replied rarely or sometimes, 70%. In short, almost all tried it, but most stopped using it. Gavin, Apple hyped Siri for its ability to understand the spoken word, and Siri captured the attention of the masses. But after time, most users were sorely disappointed with hearing the response, "I'm sorry. I don't understand that," and abandoned it after a few initial failures. B.O.B., to have so many try a product that is designed to be used daily, like the Siri, "What is the weather like today?" and practically abandon its use is not simply a shame, it is a commercial loss. The effort to get a customer to try something and lose them, well, you poison the well. Gavin, even now, if you were to play the Siri prompt, "Be-boom," a chill goes up my spine because I must have accidentally pressed it. But this feeling of a chill negatively impacted other voice assistants. Ask yourself, have you ever tried Cortana, Microsoft's voice feature on Windows OS? Did you try it? Even once? And why did you not try it? B.O.B., no. Never gave it a try. Because to me, Cortana was just another Siri. In fact, I moved to Android partly because Siri was so lame. Chapter 8, Computer in Users. Gavin, in speaking to Microsoft Cortana design and development teams, they would vociferously argue how much different, or better, their voice assistant Cortana was from Siri. But because of the failure of trust, people who used Siri tended to associate the technology with Cortana. B.O.B., ask if anyone has tried Bixby, Samsung's mobile phone voice assistant, and you get blank stares. The point violating an AI UX principle like trust can be powerful enough to prevent users from trying similar, but competitive products. This is arguably a domain-specific AI winter. These negative feelings towards Siri extended to other virtual assistants that were perceived to be similar to Siri. As other virtual assistants came along, some users had already generalized their experiences with virtual assistants as a category and reached their own conclusions. The immediate impact of this was to reduce the likelihood of adoption. For instance, only 22% of Windows PC users ended up using Cortana. 31 Ultimately, Cortana was likely hit even harder than Siri itself by this AI winter because Siri was able to overcome and still exists. Cortana was eventually repurposed as a lesser service. In 2019, Microsoft announced that, going forward, they intended to make Cortana a skill or app for users of various virtual assistants and operating systems that would allow them to access information for subscribers to the Microsoft 365 Productivity Suite. 32 This meant that Cortana would no longer be equivalent to Siri. Unlike Siri, Cortana was a vastly capable virtual assistant at its launch, especially for productivity functions. Its notebook feature, modeled after the notebooks that human personal assistants keep on their clients' idiosyncrasies, offered an unmatched level of personalization. 33 Cortana's notebook also offered users the ability to delete some of the data that it had collected on them. This privacy feature exceeded any offered by other assistants. 34 Despite these very different capabilities, users simply did not engage. many could not get past what they thought Siri represented. Moreover, interaction also became a problem for Siri. Speaking to your phone was accompanied by social stigma. In 2016, industry research by Creative Strategies indicated that shame about talking to a smartphone in public was a prominent reason why many users did not use Siri regularly. 35 The most stigmatized places for voice assistant use. Public spaces also happen to be common use cases for smartphones. Ditto for many of the common use cases for laptop computers, workplace, library, and classroom. Though in our very unscientific observations, an increasing number of people are using the voice recognition services on their phones these days. B.O.B. Perhaps the reason we do not readily think of the impact that stemmed from the poor initial MVP experience with Siri is because this AI winter lasted only a couple years, not decades. This rebirth of the virtual assistant emerged as Amazon's Alexa. Gavin, but look what it took for the masses to try another voice assistant. Alexa embodied an entirely new form factor, something that sat like a black obelisk on the kitchen counter. This changed the environment of use. Where the device was placed afforded a visual cue to engage Alexa. B.O.B. It also allowed Amazon to bring forth Alexa with more features than Siri. Amazon was determined to learn from the failed experience of its Amazon Fire phone. The Fire had a voice assistant feature, and Amazon's Jeff Bezos did not want to make Alexa's voice assistant an MVP version. He wanted to think big. Gavin, almost overnight, Jeff Bezos dropped $50 million in authorized headcount of 200 to build a cloud-based computer that would respond to voice commands, like the one in Star Trek. 36 The point Alexa emerged as a voice assistant and broke out of the AI winter that similar products could not, but it needed an entirely different form factor to get users to try it. And when users tried, Jeff Bezos was determined to not have users experience an MVP version, but much bigger. In the early days of computing, computers were seen as a means of extending human capability by making computation faster. In fact, through the 1930s, computer was a name used for humans whose job it was to make calculations. 37 But there were a few who saw computers and computing quite differently. The one person who foresaw what computing was to become was J. Licklider, also known as Lick. Lick did not start out as a computer scientist. He was an experimental psychologist, to be more precise, a highly regarded psychoacoustician, a psychologist who studies the perception of sound. Lick worked at MIT's Lincoln Labs and started a program in the 1950s to introduce engineering students to psychology, a precursor to future human-computer interaction, HCI, university programs. Human-computer interaction is an area of research dedicated to understanding of how people interact with computers and the application of certain psychological principles to the design of computer systems. 38 Lick became head of MIT's Human Factors Group, where he transitioned from work in psychoacoustics to computer science because of his strong belief that digital computers would be best used in tandem with human beings to augment and extend each other's capabilities. 39 In his most well-known paper, Man-Computer Symbiosis 40, Lick described a computer assistant that would answer questions when asked, do simulations, display results in graphical form, and extrapolate solutions for new situations from past experience. 41 Sounds a little like AI, doesn't it? He also conceived the Intergalactic Computer Network in 1963, an idea that heralded the modern-day Internet. 42 Eventually, Lick was recognized for his expertise and became the head of the Information Processing Techniques Office, IPTO, of the U.S. Department of Defense Advanced Research Projects Agency, RPA. Once there, Lick fully embraced his new career in computer engineering. He was given a budget of over $10 million to launch the vision he cited in Man-Computer Symbiosis. In the intertwining of HCI and AI, Lick was the one who initially funded the work of the AI and Internet pioneers Marvin Minsky, Douglas Engelbart, Alan Newell, Herb Simon, and John McCarthy. 43 Through this funding, he spawned many of the computing things we know today, the mouse, hypertext, time-shared computing, Windows, tablet, etc. Who could have predicted that a humble experimental psychologist, turned computer scientist, would be known as the Johnny Appleseed of the Internet? 44 Bob, with good reason. Lick was the first person to merge principles of psychology into computer science. His work was foundational for computer science, AI, and UX. Lick pioneered an idea essential to UX that computers can and should be leveraged for efficient collaboration among people. Gavin, you can certainly see that in technology. Computers have become the primary place where communication and collaboration happen. I can have a digital meeting with someone who is halfway across the world and collaborate with them on a project. It seems obvious to us, but it's really a monumental difference from the way the world was even just 20 years ago, let alone in Lick's day. Bob, we now exist in a world where computers are not just calculators but the primary medium of communication among humans. That vision came from Lick and others like him who saw the potential of digital technology to facilitate communication. The point Lick formed the basis of where AI is headed today, where AI and humans are complementary. Licklider's legacy lived on in others, particularly of note is Robert Bob E. Taylor. Taylor had been greatly influenced by Lick's ideas in man-computer symbiosis and had a similar DNA to Lick's, from psychologist to psychoacoustician to computer scientist. Lick and Taylor met in 1962 when Lick was running the IPTO at ARPA. They co-authored a paper in 1968 called The Computer as a Communication Device, 45, illustrating their shared vision of using computers to enhance human communication. 46 They begin the paper with the following two sentences: in a few years, men will be able to communicate more effectively through a machine than face. That is a rather startling thing to say, but it is our conclusion. Lick and Taylor describe, in 1968, a future world that must have seemed very odd at the time. Fast forward to today, where our lives are filled with video calls, email, text messaging, and social media. This goes to show how differently people thought of computing back in the 1960s and how forward-looking Lick and Taylor were at the time. This paper was a clear-eyed vision of the Internet and how we communicate today. Taylor eventually succeeded Lick as the director of IPTO. While there, he started development on a networking service that allowed users to access the information stored on remote computers. 47 One of the problems he saw, though, was that each of the groups he funded were isolated communities and were unable to communicate with one another. His vision to interconnect these communities gave rise to the ARPANET and eventually the Internet. After finishing his time at IPTO, Taylor eventually found his way to Xerox PARC, Palo Alto Research Center, and managed its computer science lab, a pioneering laboratory for new and developing computing technologies that would go on to change the world as we know it. We'll discuss Xerox PARC later in this chapter. But, first, let us return to the world of AI and see what that is the heart of AI and UX, why artificial intelligence needs user experience. If it helped, a quick subscribe keeps more summaries coming. So how do user and human connect? That is exactly where we started. Go back to the top and watch it click into place.